All right, so the slope formula we got here. Go ahead and write this stuff down. This is actually pretty important to have down. It's not like the most important thing in the world. We're going to show you pretty much what this means, and I think you guys will be able to not have to memorize this. However, memorizing this is going to make you a little bit quicker in the long run, so it's not bad to have. So go ahead and take a second to write that down. So what we're looking at is, if I give you two ordered pairs, this is the whole point of it. If I give you two ordered pairs, whatever they may be, can you tell me the slope between those 2 points without using a graph? And it is possible, because we don't, like Mr. Craig said earlier in a video, that we don't always have graph paper. And plus, if I had two big ordered pairs that were really far away, I don't want to sit there and have to draw a triangle to figure out what's the rise and what's the run and sit there and count. Right? So having two ordered pairs and having a formula for that is going to be nice. So let's go ahead and take a look at what this means. If I have 2 points, x1, y1, and I have another point, x2, y2, what are these 1s and 2s? Well, this is just saying this is my first x coordinate, and this is my first y coordinate. This is my second x coordinate, and this is my second y coordinate. This is my first point, this is my second point. That's all that's saying. If I have two ordered pairs here, I can find the slope by finding y2 minus y1, and then dividing that by x2 minus x1. But really all you have here, and this is why it's so easy to remember, is you just have your change, or your difference of your y's, it's your change in your y's, over or divided by the change in your x's. And that's why this is so easy to remember. The only hard part is trying to remember which y goes first. y2 minus y1 over x2 minus x1. That's the only hard part. Okay? But it is just really your change in your y's on your graph over your change in your x's on your graph. Let me show you what that looks like here. So I got the formula up here. But if I give you an ordered pair, 2 comma negative 3 and 1 comma 4, it's really actually easy to find the slope. Instead of having to sit here and draw a graph and go, well, 1, 2, 1, 2, 3, that's 2 comma negative 3, and going up over 1, 1, 2, 3, 4, and then trying to figure out your slope by drawing a triangle, again, these points could be really big. It might mean a really big graph, and that would just be impossible, right? So instead of doing that, we can actually just use the slope formula here. I have everything kind of labeled already for you. Your x1, y1, x2, y2. Now it's just all about substituting those values in. Well, let's take a look. What is y2? Well, y2 is 4 minus y1 is negative 3. We'll get back to that in just a second. In the denominator, we have x2, which is 1, minus x1, which is 2. So let's kind of work on this a little bit. I know that minus a negative is just going to turn into a positive, and 4 plus 3 is 7. And then 1 minus 2 is a negative 1. And 7 divided by a negative 1 is a negative 7. So my slope would be negative 7. And that's it. That's what my slope would be. In other words, on my graph, I'd have to go, this would be rise over run if I took a look at that. I'd have to rise 7. So it would go up 7 and then to the left 1 to get to my other point. And that looks pretty good on the graph too. This can be kind of cumbersome. There is another way that we can look at that though, so let me show you on a different example here. I got two ordered pairs again, and I could go through the slope formula. Actually, I'll take you through that really quick again, and I'm going to show you kind of what I think is an easier way, and might be an easier way for you as well. Let's go ahead and find the distance between 4, 7 and 8, 9. Actually, why don't you try it? Plug it into the slope formula and see what you get. All right, so here we got m equals, let's do my fraction, y2 is 9 minus your y1. y1 is 7. And then x2 is 8 minus x1, which is 4. 9 minus 7 is 2. 8 minus 4 is 4. And then 2 over 4 would reduce down to 1/2, right? So let me just move this over a little bit so I can fit that in here. 2 over 4 is 1/2. Okay, so that would be our slope between those 2 points. But here's another way we can look at it. Since we already know what rate of change is, and we already know how to use tables, we find the change in the y over the change in the x, we can actually put these two ordered pairs into a table and then just find the rate of change. And rate of change is the same thing as slope. So what I'm saying is I've got x1, y1, x2, y2, my first ordered pair and my second ordered pair, and I'm just saying, okay, how can I find the slope here? Well, we just have to find our change in y over our change in x. In our previous video, we talked about how the change in y over change in x is our rate of change, which is the same thing as slope. So if I put these ordered pairs into a table here, 4, 7 and 8, 9, and find my change in y.
But I thought y2 had to go before y1.
y2 and y1? Oh, yeah, so it actually doesn't matter what way that you put your ordered pairs in, as long as you put your ordered pairs into your table. As you can see here, we got x1 and y1, 4 and 7. This would be my x coordinate 4, my y coordinate 7, so 4, 7. And then I have my x coordinate, my y coordinate 8, 9. It actually wouldn't matter which order I put those in, as long as it's 4 next to 7 and 8 next to 9. Does that answer your question?
Yes.
Okay. So the change in y here would be, how do we get from 7 to 9? Well, that would be plus 2. How do we get from 4 to 8 for our change in x? That would be plus 4. And again, we talked about this a little bit. The slope is really just the change in y over the change in x, right? Your rise over your run. And so my change in y here is 2 over your change in x, which is 4. And 2 over 4 is 1/2. And you'll notice that we got the same answer as we did before. Okay, one took a little memorization. It took a lot less work because in this one we had to draw a table. But if you don't remember this, is that okay? Absolutely, because we could just put the points into a table and find the rate of change between those 2 points. Because rate of change and slope are the same thing. All right, so what does this tell me about all these things? Well, let's take a look. You're going to have to describe graphs and slopes and rate of changes. And we want you guys to have this concept down. So we're going to go through this every time now. Would this graph, if we were to graph this, would it be linear, exponential, or neither? Well, I don't know a whole lot from this. But because I have a table and I can see that the rate of change is 1/2, I'm probably just going to go with linear, and that is okay to take a guess there on linear. Is it increasing, decreasing, constant, or neither? Well, is the slope positive, negative, no slope, or 0? In this case, we have a positive slope. In other words, if this were rise over run, we'd start at a point, we'd rise 1, run 2, right? Rise 1, run 2. And if I kept on doing that, I would have a increasing slope. It's a positive slope, and positive goes with increasing. Is it a function? Well, from the points that I have, there are no repeating x values, so I'm going to say yes. So is the slope positive, negative, no slope, or 0? Well, we just talked about that. It's a positive slope because it didn't come out negative.
So you found all that out from 2 points?
Found all that from 2 points.
That's impressive.
All right, so pause the video, and now you try all of that out for this one. All right, so I've got 2 points, and a couple of the questions, we'll just go from all these, but we'll go to the what is the slope here in just a second. Is this linear? It looks like a straight line to me. Is it increasing, decreasing, constant, or neither? Well, as I read it from left to right, it's going up, so that's going to be increasing. Is it a function? Yeah, it passes the vertical line test, so yes. What's the slope? Positive, negative, no slope, or 0? Well, positive, negative, no slope, or 0. It looks like it works with positive, so I'm going to go with a positive slope. And that should actually help me find out what the slope is, which is the next question. And I'm just going to go straight to the table because I think that's easier. I'm going to plug my 2 points into my table, so negative 4, 3.
Does it matter which one you put first, Mr. Nelson?
And 1, 5. No, it does not matter what order that you put these in. You could have put 1, 5 first, and then negative 4, 3, as long as you have your x, y, x, y. All right, let's find my, again, slope is always your change in y over your change in x. So let's go ahead and find those two things. My change in y on my table over here, 3 to 5.
Plus 2.
Plus 2. That's my change in y. Let me write that above there. So my change in y is 2. My change in x, how do you get from negative 4 to 1? That's plus 5. So positive 5. 2 over 5, and actually kind of makes sense because 2 over 5 is positive, and we just talked about how the slope is positive. So what is the slope? The slope is 2 over 5, or 2/5. All right, so pause the video, give this one a shot. All right, so here we go. I'm going to go ahead and throw these ordered pairs into my table first because I need to answer all these questions, right? So I'm going to take my ordered pairs in here and go negative 3, 3, and 2, 3. Again, we're looking for the change in y over the change in the x's, and that's going to help us find the slope. So going from here and finding the change in y and the change in x's should help us find our slope. So my change in y is, looks like plus 0 to get from 3 to 3, and then how do you get from negative 3 to 2? That's plus 5. And so my slope is that change in y over change in x, which in this case is going to be your 0 over 5, which 0 divided by 5 is just 0. So to answer this last question, kind of right up front, is going to be m equals 0, and that's going to tell us a lot about the rest of this question. Does this graph look linear? Looks linear to me. That's a straight line. Is it increasing, decreasing, constant, or neither? Well, it's going from left to right. It's not going up or down. This is what we call constant. Remember, neither is your straight up and straight down. Is it a function? Yes, because it passes the vertical line test. Is it slope positive, negative, no slope, or 0? Well, if you do the song, you got positive, negative, no slope, or 0. In this case, we also found out that it was 0 too. What is the slope? It's 0. All right, go ahead and pause the video and try this one. All right, so we have the 2, -5, and then the 0.7, -10. And we have to answer all these questions again. So is it linear, exponential, or neither? Can't really tell yet. Increasing, decreasing, constant, neither, so on and so forth. I'm going to go straight to the table, substitute my values into my boxes here. 2, -5, and 7, -10. Again, our slope is your change in y of your change in x.
Rise over run.
Or your rise over run, if you put this onto a graph. -5 to -10 is actually going down, so our change in y is -5. To go from 2 to 7 for our change in x, though, would be actually increasing by 5. So change in y is -5. Change in x is your +5, and -5 divided by +5 is just a -1. So that tells us a lot about everything here. Is it linear? Well, I don't have a graph to look at this time. So is it linear? Well, from what I can tell, I only have one rate of change, which is -1. So I'm going to go with linear, from what I can tell so far. Is it increasing, decreasing, constant, or neither? Well, I can tell this from my slope. Because it's a negative slope, we know positive goes this way, negative goes this way, and we have a negative slope here, so negative slope is decreasing. Constant would be straight across, like we just talked about, and neither would be straight up and down. Increasing would look like a positive slope. All right, is it a function? I don't see any repeating x values. Yes. Is the slope positive, negative, no slope, or 0? Well, it's a -1, so we're going to say it's negative. And then what is the slope? N equals a -1. Let's try the next one. Pause the video, give it a shot. Okay, let's move on from there. 5, 0, and 0, -6. Again, finding the slope is always change in y over your change in x. Let's write this over here really quick so we never forget. Change in y, how do you go from 0 to -6?
-6.
-6, and how do you go from 5 to 0?
-5.
Also -5. So our change in y was -6, change in x is -5. A negative divided by a negative is positive. I'm going to leave this as 6/5. This is the reason why. I don't want to rewrite this as 1 1/5, and I don't want to rewrite it as 1.2. They're both correct. They both are the same thing as 6/5. But remember, slope is your rise over your run. Right? You're changing your x over your change in y's. And if I say, hey, 1 1/5, what's your rise? Is it 1? No. Your rise is 6, not 1. What about 1.2? Right? It's really hard to see your run and rise, so when we get to graphing, having it as an improper fraction is going to be a lot easier. And so we're just going to have to live with improper fractions. They're going to be considered proper in this class. So let's think about the graph here for a second. Is it linear, exponential, or neither? I only have one rate of change to look at, to compare to, so I'm going to go ahead and say it's linear. Is it increasing, decreasing, constant, or neither? Well, that has to do with the slope. Again, it's 6/5. It's a positive slope, and positive slopes increase as they go from left to right. Is it a function? Also yes, because I have no repeating x values. And what is the slope? Well, we just talked about that. It's 6/5, or 6/5. Next up, go ahead and pause the video, give it a shot. All right, 5, 2, and 5, 10. Again, we're always looking for our change in our, yep, you guessed it, change in y over your change in x. So our slope is always your change in y over your change in x. Change in y, 2 to 10 is
8.
plus 8. 5 to 5 is
0.
Plus 0. Our change in y is 8 over our change in x is 0. And then we go, uh-oh, Mr. Nelson, what do you do? Well, 8 divided by 0, can you divide by 0 is the question. And the answer is no, not math. So this doesn't work out, right? Doesn't do anything. This is all rise. We're going, so basically we're just going up, rise, 8. Is that 8? That works. But we're not running anywhere. We're just going straight up and down. And what we call that when we're talking about slope is no slope. No slope. It's also known as undefined. But for the sake of this class, we're going to go with no slope. All right, is it linear? As far as I can tell. I mean, if it's no slope, we know that no slopes go straight up and down. There's a positive, negative, no slope. I'm going to go with linear. Graph, is it increasing, decreasing, constant, or neither? Well, we know this is increasing, this is decreasing, this is constant. That must be none of those, so neither. Is it a function? Also no, because it's going to fail the vertical line test for two reasons. It fails the vertical line test, as well as how many x values are repeating here? Both of them, right? So this is definitely not a function. Is it positive, negative, no slope, or zero? Well, we just talked about that. And then what is the slope? There isn't one, right? It's no slope. So that's what you'd have to, hopefully, is what you actually got when you tried the problem out. All right, let's try this one out. All right, here we go. 6, -1, and 4, -1. Change in y over change in x is how we're going to find the rate of change, or the slope. So let's write that down really quick so we never forget. Change in y is 0. And our change in x is -2. Change in y was 0. And our change in x was a -2. 0 divided by -2 is possible. That is just 0. Okay, is it linear, exponential, or neither? I'm going to go with linear because the only rate of change I have is 0. Is it increasing, decreasing, constant, or neither?
Constant.
This is going to be a constant. There's a 0 slope, a positive, negative, no slope, and then a 0 slope would look like this, and that's what constant looks like. Let's move on to function. Would that be a function?
Yes.
This would be a function as well as we don't have any x values repeating. It's a function. So positive, negative, no slope, or 0. We got 0 slope. What is that slope? Well, it's 0. It's kind of redundant at that point.